We're going to start with number 12, which is Jenna. Okay, Jenna, we're trying to find the equation of a tangent line to the graph of f at 0, 1 for f of x equals that. I'll just let you start to tell me anything. I can guide you if you would like some guidance, but... Oh, that was a yes? Okay. Do you remember what we need to write the equation of a tangent line?
A point and slope.
Perfect. Okay, so that's not a marker. That didn't help. Where's the markers? So we are specifically trying to find a point and a slope to write the tangent line. Now, luckily, we already have the point. We were given the point. We don't have the slope. Do you want somebody else to do that part?
Sure.
Okay, that's fine. I mean, knowing how to find the tangent line is actually where a lot of students will get stuck. So that's a good start. Who do we have? 30. I don't think we have... Oh, yeah, we do have 30. Maria. You're on Instagram.
I was deleting my stuff, sorry.
How do we go about finding the slope with that equation?
Like the slope at any point or the slope at that point?
Either or, but at the end of the problem at that point. But most people approach it to find the slope at any point and then put that in a number. How do we find the slope of this function, which would be f prime? I believe we did this one as an example, but we're going to pretend that we didn't. Do you want some reminders?
I don't know if I should use the quotient rule
Or
like put in like the h plus x thing and it's all over h.
You want to completely forget that limit process if you can.
Okay.
Not that it's bad, but it is definitely slow and, well, really slow. And for this problem with that function, it would be pretty horrible. So how do I find the derivative of this? Correct, with quotient rule.
Oh, so I use quotient rule?
Yeah, because it's a quotient.
Okay, so f would be cosine x.
That's what you're giving me these for?
Yeah,
Okay.
and then f prime is negative sine x.
Good, good, good.
And then g is 1 minus sine x. And then g prime is cosine x. Okay,
That sounded like a question.
it is.
Oh, it is. Good. So when you have negative sign, the derivative, the derivative of sine is cosine. The negative that's on the sign would stay with it.
Oh,
So negative cosine. Okay, but very good. I mean, like you were pretty much just doing those off the top of your head. So now we need to fill in the quotient rule. Should we have somebody help us do that? I did not leave enough room at all for that. Okay, Jameson, who do we have? 16? Wait, I forgot to give people candy already. I'm definitely not going to throw it that far. You can come grab it at the end whenever you want.
Yeah, Mr. Hayes chucks it that far.
Yeah, I know, but like I already hit somebody in the head last hour, so.
Well, he hits people in the head all the time.
I like it how you throw that out like it's acceptable.
This is candy.
Well, Starburst can get really hard though. Like they're supposed to be soft, but
He just chucks zaps. Yeah, he throws zaps.
okay, Jameson, who do we have? 16. Grace. I don't think you were here for quotient rule, but were you able to take a look at it? That's at least that's confidence, like thinking that you can just do it without trying it ahead of time. But you are correct. It's just a formula you fill out. It looks like you're looking at it right now.
Yeah, this.
I don't know. I can't see that, but
Yes.
okay.
Okay, so I would just like plug in,
Yep.
so 1 minus sine of x
Okay, so G, correct?
times negative sine of x minus cosine of x times negative cosine of x.
Good. Very good.
Oh, and then that's over.
1 minus sine squared. No, that's perfect. That's all there is to the quotient rule is finding the parts and then just filling it in. That's pretty much the hour you're gone for. Okay, now here's the part that's different. If you want to simplify this, you can. Without rolling, can anybody tell me why we don't have to simplify? Like, if you want to simplify this, you can, but can anybody tell me why we don't need to?
Could we just insert the point?
I think you said it.
Actually, never mind.
Oh, okay. What did you say then?
Could we just insert the point?
Yes. Because we're trying to find the slope at 0, 1, this is the slope. It's not simplified, but this is the slope. So I can just put x equals 0 in now and then find out what the answer is. I've usually had better luck having students do this rather than simplifying first because the simplification process seems to be where a lot of people make mistakes. So if I plug 0 in now, I don't really even have to worry about it. So 1 minus sine of 0, which is 0, times negative sine of 0, which is 0, minus cosine of 0, which is 1, times negative cosine of 0, which is negative 1, all over 1 minus 0 squared. Oh, I forgot the prime, sorry. F prime of 0 is, so I've got 1 minus 0, which is 1 times 0, which is 0, minus negative 1. So my numerator is 1. Denominator is 1 squared, which is 1. So my slope at 0 turns out to be 1. Now, I only used x equals 0. And I don't know if you noticed that or if I need to point that out. When you're trying to find the slope at the point 0, 1, I only needed the x value. I didn't need the height. And you're going to run into situations like that, so I'll point it out, but I didn't know if that was obvious to you or not. How are we so far? Okay? I already forgot that. I'm really bad at remembering to throw candy. So if you guys answered and you want some, feel free to come grab it. Okay, are we ready to finish the problem? Or does anybody have questions up until there?
So why did we change it to 1 and 0?
I was trying to find the slope at the point 0, 1. The derivative represents slope anywhere. By me plugging in x equals 0, this is the slope at x equals 0. And that's what I'm trying to find. Okay, Jameson, who do we have for the tangent line? 29. You guys probably already know who it is. Rosa. How do I write the tangent line with my information that I figured out now?
Y equals m times, or slope times x1 minus that. It's something like that. Some kind of equation.
You're spot on so far.
Oh, okay.
Just
Y
trust yourself.
equals m times x1 minus x,
Reversed, but yep,
x minus x1. And I know there's a y minus.
it is. Okay, so the packet had you guys write y equals m times x minus x1 plus y1. And if you want to write that way, that's fine. This is still point slope form. The way that we were kind of taught it from our textbook from Algebra 1 and Algebra 2 was y minus 1 equals 1 times x minus 0. They're both correct, though, so it's whichever form you want is fine. On the AP test, you can pick whichever form. So if you've gone through and kind of memorized it the way that the packet had it, go for it. I'll know which one. I mean, like, I'll know that they're both correct. So you can leave it like this. This just says find an equation of the tangent line. It doesn't say find it in slope intercept or anything. It just says find an equation. And this is an equation. Good. This has nothing new in it, but I thought it was a good way for us to review what we did last week. Now we move on. And I don't know if this is this horrible? Oh, all right. Well, then we better call on somebody for this. I already keep forgetting. 19. And this person, Teddy. Teddy, you can blame Jameson. So, how do I go about doing this, Teddy? And I can certainly help get you started, but I thought I'd give you the opportunity if you kind of knew already. Okay, no problem. So if I'm trying to find the derivative of cosecant, I'm trying to find f prime of theta. What I'm going to do is I'm going to change cosecant in terms of sine and cosine. And I'm going to write this as 1 over sine of theta. Now, conveniently, 1 over sine of theta is written as a quotient. So how do I do the quotient rule on 1 over sine of theta? That's what I was hoping you could help me set up. Okay, f is 1. You are correct. F. Perfect. G is sine.
I mean, I've done G prime.
Yep. But yep, you're correct. Yep, correct. The information actually is going to be pretty easy to put in there and do because half of it cancels out from that 0. So quotient rule would be G times f prime, which is 0, minus f, 1, G prime, cosine, over G squared. All right, so I'm going to simplify this down. 0 minus cosine theta would be negative cosine theta on top. On the bottom, I've got sine squared theta. Now, is that big enough for you guys to read okay? Okay. Sometimes it gets really difficult to fit all this information in. Teddy, very nice job, though. Now, this isn't wrong. What you're going to find is, for whatever reason, whenever you have trig functions, they traditionally like to write them as numerators or all, like all on the numerator if they can, whatever. And so this one has a lot of different correct ways it can be written. I will show you the way that you're traditionally going to see. But I wouldn't mark you wrong if you wrote a lot, like if whatever you wrote was correct. The way that you're traditionally going to see this is negative cosine over sine times 1 over sine. Oh, I wrote those backwards. Not that it matters at all, but the 1 usually goes first. And I'm only going to want them right. I'm writing them the other way so that you can memorize them the way that you'll see. So the derivative of cosecant that you are traditionally going to see is negative cosecant theta times cotangent theta. because 1 over sine is cosecant. Cosine over sine is cotangent. Now, I realize right now, this feels like I made it harder for no reason. You will see why in a second. Now, I guess what I wanted to know was, do you guys want me to take you through to do these other 3? Oh, really? Shoot. Okay. Can I skip secant since it's the same as cosecant? You would do 1 over cosine and then do the quotient rule of 1 over cosine. Tangent and cotangent are different because the fraction you create, it doesn't have 1. So let's do tangent together. I feel like we did this one. No, we didn't do this one together. I just told you the derivative was secant squared, like 3 sections ago. Okay. So I think that was when we did power rule. You learned sine, cosine, tangent. So what I'm going to do is I'm going to write tangent as sine of theta over cosine theta. Basically changing it into a fraction with sines and cosines allows you to do quotient rule. Now, if I do f prime of theta, I'm going to do g times f prime minus f g prime over g squared. Now I'm trying to save a little bit of time by not putting in f prime, g prime on the side. But I know you guys know how to do that if you wanted it for your notes. Now in terms of simplification, this one actually works out really nicely because I end up with cosine squared plus sine squared over cosine squared. And that turns into 1 over cosine squared, which is secant squared. So this is how they came up with the derivative of tangent is secant squared. Now, I believe the top of the next page is where it says you're supposed to memorize all 6 of these. Yes. Okay. I would like to write them differently because I want to show you the pattern, which to me helps memorize these much better. Not that the way that they were written in the packet is wrong. I just find it's better to... Okay, derivative of sine, you guys know. Cosine. Derivative of cosine, negative sine. Okay, these are the 2 main ones, and my guess is you guys already have these memorized. So probably your job from here on out is to memorize the other 4. So let's write out tangent. So the derivative of tangent was secant squared. Now here's where the patterns come in, which is super nice. We did tangent, so the next one we're going to do is cotangent, the co-functions. If this derivative is secant squared, does anybody have a guess as to what this derivative is going to be? Cosecant squared. The co-functions have co-derivatives. Okay, then I'm going to do secant, the derivative of secant. Oh, we did cosecant, didn't we? Shoot, I should have planned that better. The derivative of secant is secant tan. So then the derivative of cosecant is cosecant cotan. Oh, I almost completely forgot and completely screwed up your notes and your derivatives. I 100% forgot something on these derivatives. Given the pattern of sine and cosine up above, what did I forget on the second derivative each time? The negative. It's negative, negative. I almost forgot that, and that would have been real bad. But I wanted to emphasize and point out there is absolutely a pattern to this. If you guys can memorize the derivative for tangent and secant, you automatically have their other derivatives. So when you're doing a test, what a lot of students have done in the past, oh, I need to tell you about the schedule. On a test, what a lot of students have done in the past is at the very top of the test when they first get it, they write out the trig derivatives. And then that way during the moment of the test when you're getting stressed, you're not going to forget them. Okay, I'm going to pause the notes to go over the schedule with you guys, just so you guys know what we're doing for the next 2.5 weeks to the end of the try. Our original plan was to try to get 3 full tests in the trimester. And it's definitely clear we're not going to be able to hit that. I forgot how long 2.7 is, so there's no way we can do 3 tests. But I also want to give you guys the opportunity to raise your grade if you want. So what we will do is we'll have 2 more scores in the summative category. So we're going to do the quiz on 2.5 to 2.7 on Tuesday, and we'll make that probably about the same as the quiz we just took, like 17-ish points. But it'll go in the summative just to give you a chance to raise your grade if you want. And then we're going to make it so that the questions are easily gradable so that I can get them graded by the next day so that we can go over the quiz and finish reviewing the chapter, just so you guys know what things you might be making mistakes on before the test. And then we'll take the test that Thursday on the second half of 2. Yeah, I don't think it's all of 2. I better double check on that. I'm pretty positive it's just going to be a test on the second half of 2, but I'll double check. Yeah, that would definitely make a difference. I'll check on that one. But either way, we'll take our test that Thursday, and then this way you don't have to take a test on the finals days. And that should help you out with the other classes, but it still gives you the chance to do 2 more scores in the summative category to raise your grade to get it wherever you'd want to. And then we'll start the next chapter that Friday, Monday, Tuesday, whatever. And then, but like I said, that way you also won't have to do it those last 2 days when you're probably going to be taking quite a few tests. Does that work okay? Okay. We tried to set it up so that there was 2 more scores for you to put in to affect your grade. Okay, anyway, I wanted to say that before I forgot it. Now, I will tell you that when we go to exercise 5, the next part of the notes, I'm pretty positive this was here on accident, because you don't know how to do derivative of this yet. I'm positive this was intended to just be 1 over square root of x. I mean, I looked in her filled out notes, and she has it filled out, but you won't know how to do that one until you learn the chain rule in chapter 3. So this was supposed to be 1 over root x. And the only point of these 3 exercises here is they're currently set up for the quotient rule, but if you have a single item in the derivative, you can always rewrite it so that you bring it up to the numerator and multiply it out, or you could just do quotient rule and product rule, anyway. But if you wanted to, having a single item in the denominator allows you to rewrite so that you can just do power rule. Like this one, we've definitely done this one before, and you could rewrite it as x to the negative half to do power rule. And we've had examples of all three of these. They're only in here to show you that you don't have to do quotient rule, but you can. Quotient rule would get you the same final answer, but with a lot more work. Like this one, I would rewrite as 6x to the 3 halves. Well, this is dumb. That doesn't work here. Minus x to the negative 1 e to the x. So I would still have to do product rule right there. I wonder if that was intended to be an e to the x. Was everybody okay where I got 3 halves power from, by the way? Are you getting better at doing some of those algebra work in your head, that like getting used to it? Because we do a lot of the same algebra work repeatedly, and you'll get used to it, but you'll have to find out. Okay, so this one I'm going to subtract x to the half from each power. So I'm going to have 6x to the 3.5. What would that be? 7 halves? Plus x to the 3 minus a half, so 2.5, 5 halves, minus 2x to the 1 minus a half, so a half.
Where did you get the 7 halves from?
So the denominator is x to the 1/2 power,
Yeah.
and if you're dividing like bases, you can subtract their powers. So I did 4 minus a half, so the power's 3.5. But you can't write them as mixed numbers, so. Yeah, I mean, like, these 3 problems technically are in this section, but they don't have to be. You could have done them with quotient rule from the beginning, and it would just taken you a really long time. Okay, I want to skip to the last part so that we can talk about it and get done with it. Higher order derivatives, which sounds worse. It sounds worse. Have we talked about how the velocity is the derivative of position? Okay. I couldn't remember if we did it in limits or not. Maybe we did, and you just really wouldn't even have really known what derivatives were back then much anyway. Okay. Well, if you look at your position function, the derivative of the position function, let's just say position is in feet. If I take the derivative of something that's in feet, do you remember what derivative represents? Like, I know you're going to say slope, but do you remember what slope represents? It represents the rate of change, like how fast something's changing. So if I take the derivative of feet, I'm going to get feet per time unit, probably seconds. Could be minutes, whatever. But if I take the derivative of position, I get velocity. If I take the derivative of velocity, what I'm going to do is I'm going to find my velocity, how fast the velocity is changing. So feet per second, which happens to be feet per second squared. So the derivative of velocity gives you acceleration. And you probably wouldn't have noticed it. Do you remember how you were given these formulas in physics? Oh, why am I writing feet? S of t. So let's look at the free fall one for an example. Free fall was 1/2 at squared. Is that how you guys were given it? Or did you just automatically use meters per second? So like negative 4.9 t squared. Maybe, okay, I'll just write 1/2 AT squared. How many of you were in physics? Oh, not as many as I thought. Okay, well then we're going to pretend you know these. Maybe I'll put numbers in then, since many of you weren't in physics. I'll just put numbers in. This will be acceleration due to gravity in meters per second squared. The second number is the initial velocity that you drop or throw something down or up at. So let's just say we're going to take something and throw it straight down. So minus 5 feet per second. No, meters per second. And the third number is the initial height. So let's say we're going to start it at a height of 20 meters. So that's what this equation would represent. If I take something from a 20-meter tall building and I throw it down with an initial velocity of 5 meters per second, this would be acceleration. That's the kind of formulas you were given probably, right? Okay. So the derivative of position would be velocity. And if I do power rule, I would get negative 9.8 t minus 5 plus 0. And the derivative of velocity is acceleration. And if I do the power rule on velocity, I would get negative 9.8. Now, that should look familiar to you because negative 9.8 is the acceleration constant due to gravity. If you were like me as a student in physics, like it always kind of blew my mind how on earth they came up with this top formula. Like it just seemed like such a random one full of all sorts of weird numbers. Like it semi made sense, but like you're wondering how somebody figured that out in the first place. Well, what you're going to do in the second half of calc is we're going to learn something called antiderivatives. So it's backwards of derivatives. We start off with acceleration, which you can measure. And then we do the antiderivative to figure out velocity, do the antiderivative to figure out position. And that's how they came up with these formulas, is they used the calc part of these formulas to figure them out. And that's how most of the physics formulas are calculated. You start with something you know and you build off of it. Okay, that was a lot more than I was intending to tell you, but it's going to be important for the next section. 2.7 is all on this. So I wanted to give you a background. This is just different ways of writing notation. As long as you recognize them, you'll be fine. This is the most common notations. The y primes and the f primes. The final two columns are traditionally for something you haven't learned yet called implicit derivatives. And then the last column is almost like a verb. Like if you have a function, this is how you write that you're taking the derivative of it. So the first two columns are more common. But the second derivative is the derivative of the first derivative. The third derivative is the derivative of the second derivative. And this is how they phrase them and find them. So you're just basically taking derivatives repeatedly. And they do represent things. So we get down here, and then these are the types of questions you'll get. Now, you may not understand what they're for yet, and that's okay. This says, find f double prime of x given this. Now, I don't know if you probably haven't thought ahead far enough yet. This one is going to work out relatively easy because we're just doing the power rule. But once you start doing like the quotient and product rules, just think of the answers you get from those. Then you're going to have to take the derivatives of those. And it gets really messy. And so that's why learning how to simplify your answers helps you out a lot, because otherwise your multiple derivatives are horrible. But we're not going to get there yet. We're going to work our way into that. So f prime of x would be my first derivative. We should probably call on somebody. I haven't called on somebody for a while. 2. Tolkien. Hi.
You want me to do the first one?
Yes.
Okay. So I already.
I don't know why, but that shirt you're wearing with the mustache reminds me of the guy from Sonic.
Sonic?
No, what's the bad guy's name again?
Dr. Eggman?
No, is that actually his name? Dr. Eggman?
Yes.
I don't remember that, but that you guys sound pretty much in agreement on it. That's a horrible name.
Yeah, it's pretty bad.
Is that who I'm thinking of?
I
Like
don't
Jim
know.
Carrey had the weird mustache?
Yeah.
Yeah.
Dr. Eggman.
Okay. Eggman. Oh,
Um,
my apologies. I didn't know his name was that terrible. I thought it was something cool.
So,
How do we find the first derivative?
well, I used just power rule.
Yep,
I've
yep.
already done it. So I said it was 9/2 x squared plus 10x minus 6.
Perfect. Do you want to just go right away through and tell me second derivative, or should I go to somebody
I
else?
can do it.
Okay.
I just did 9/2 times 2, and it's 18/2, so I just got 9x.
Good.
Plus 10.
Good. So when you're doing power rule, the derivatives, they go pretty straightforward. Once you're not using power rule, then they start getting to be large. And so this doesn't work out too bad. I don't think I need to do b, but this basically says the fifth derivative. They stop using these little apostrophes after 4. So then what they do is they start putting the number in parentheses. So this would represent the fifth derivative, which we're not going to find, but I'll just put that there. That's how you'll see it.
Then what about the 867?
Oh yeah, we're getting there. We're getting there. That looks terrible though, doesn't it?
So for the fifth one, would you just do like the same process you did for the second one?
Yeah, you just do it 4 times. Yeah. Yeah, there's basically going to be nothing left because this is a fourth powered equation. And so when you do the derivative 5 times, it's just going to be 0. Because you'll end up getting to do the derivative of a number. Okay, D. I thought we'd go straight to that one because it looks imposing. This is the question you will get on the AP test. Because it's not something you can just manually do. You have to know the pattern. Otherwise, you're not going to take the time to find it. All right, so we have y equals cosine of x. Does anybody think they know what we're going to do with this ahead of time?
Yes.
Because it just keeps repeating itself in a cycle. So
Yeah.
you just find which part of the cycle it's at.
Yeah.
Yeah, because cosine and sine, they're each other's derivatives. Because they're each other's derivatives, it ends up having a repeated cycle. So once you're going to get to a point where you're going to know exactly what the derivative will be ahead of time because it's going to keep repeating. So I'm going to write the derivatives until I get back to cosine of x, because then it would start repeating. So y1, first derivative, is going to be negative sine. Second derivative, negative cosine. Okay, so we're not back to the original. We're close. Third derivative, sine. Okay. Fourth derivative, I'm just going to write 4. I'm not going to. Now we're back to cosine. So I can see that these 4 will keep repeating. So 4, 5, 6, and 7 are going to be the next cycle. So what I need to do is I need to figure out how 867 fits in to which one of these 4. So I am going to look to see how 4 divides into 867, basically. I'm assuming somebody might have already done that, I don't know. So 2, 1,
868.
27, 6, and 3/4? Is that right?
Yes.
The 3/4 part is right too? Okay. So it goes in 216 times perfectly. So looks like right here. So you see how I wrote 4, 5, 6, 7 on the next set? The perfectly divided number is the first one because that's a multiple of 4. My remainder of 3/4 tells me that 867 is 3 past the perfectly divided one. So 1, 2, 3. 867th derivative would be right there. So it is going to be the last one, sine of x. So you're going to use patterns to kind of figure it out. I wanted to show you how I do it rather than use some sort of formula, because that's most likely what you'll remember how to do on a test. Are we okay with that pattern?
Yeah.
Okay. I was trying to show it how I would figure it out and how you would figure it out. I mean, like, there's more efficient ways, but this is kind of how you'd probably do it on a test. I don't know if I want to do this one yet. This is part of the next section. Is that the last page of notes? That's what I thought. I'm going to hold off on 7 because that's supposed to be part of 2.7. I know I sort of explained it already, so if you want to try 7, you can. Okay, let's stop there. Look at that. I finished with